simply load up a water sample and you push a button, and 30 minutes later it gives them a complete analysis of what is in their water supply. And this is something that simply does not exist by any other tool at anywhere near this price on the market.
Researchers at Sandia National Laboratories and the Parker Hannifin Corporation have developed the Parker THM Analyzer, an easy-to-use system to detect hazardous chemicals in water, helping water utilities better manage the delivery of healthier, safer drinking water to the public.
What Sandia has done is a research project, and we have commercialized the project. It's a whole big transition from a research project to come to a commercial product.
This particular analyzer is designed to detect trihalomethanes. 4 compounds make up this class of chemical, and studies have shown that excessive amounts of THMs in drinking water can cause serious health problems. Ironically, they result from cleaning the water, often using chlorine.
Typically, water utilities would simply put in more chlorine than they needed in order to make sure that there would be no plagues going out to the community like typhoid and cholera. The downside, of course, was that the excess chlorine does react with naturally occurring organic matter in the water supply, resulting in the formation of these disinfection byproducts such as the trihalomethanes.
The U.S. Environmental Protection Agency currently regulates acceptable levels of THMs, and more stringent rules will take effect later in 2012.
Up until very recently, the regulation had water utilities do measurements at 4 different locations at their water storage facilities, average those 4 and report them either quarterly or annually depending on the size of the utility. And the average of those had to be below 80 parts per billion. The stage 2 recommendations, which are going into effect starting this year in the United States, actually require all 4 measurements from different parts of your facility to be recorded separately, and they must all be kept below. This has created a regulatory nightmare for the public water utilities.
Current measurement methods include sending samples to off-site laboratories, which is time-consuming and expensive, or using field monitors that can also be costly and often provide limited information. Parker and Sandia's solution lets users understand the presence and fluctuations of individual THMs in about 30 minutes. The design is based on years of research with surface acoustic wave, or SAW sensors, and a new product, laser-deposited nanoporous carbon coatings.
The key factor really was involving Mike Siegel and the nanoporous carbon. That was really what took us from parts per million to parts per billion.
The nanoporous carbon film coated SAW detector is the heart of the Parker THM Analyzer. It's essentially the key component that separates this tool from everything else that's out there on the market, and allows us to take a technology that involves purging and collecting and separating. But now we've brought in a new detector capability that it's enabling us to see literally orders of magnitude lower concentrations of analyte chemicals than anything else that's out there, with the exception of incredibly expensive laboratory equipment.
The fact that the nanoporous carbon is very reproducible and can be made over and over and over again on these devices, and the first one is the same as the 10th one, is the same as the 100th one, is a key to any commercial entity selling a product.
The water utility in Las Vegas, Nevada is one of many facilities that have recently purchased a Parker THM Analyzer.
What we have been doing was sending our samples to the laboratory for measurement of the THM content, and it took quite a long time until we get those results. And in between the results, you can say it's as if we were working in the dark. What happens now is, if we make a change, or if we are trying a certain system towards removing the THM, we can immediately measure the effect of that new introduction to the system and find out whether we are in the right direction or in the wrong direction, or if we have to optimize some of our processes. In that way, having the result under 1 hour has no other alternative, and this happens to be really one of the best things we have acquired as far as measuring THM is concerned.